Make encoder great again in 3D GAN inversion through geometry and occlusion-aware encoding. We present a novel EG3D-based encoder to invert a monocular image and synthesize multi-view results. Our framework is well suited for downstream applications such as semantic editing. Due to inversion is the reverse process of generation, it's necessary to understand the characteristics of EG3D's latent space. Thus, we explore and analyze the properties of W latent space and F feature space in EG3D. We adopt a fixed C and sample various pose conditions, P, to generate corresponding latent code, W. Then we used the pre-trained EG3D to synthesize multi-view results under different camera poses. We found that the pose condition determines the quality of rendering images, feature maps, and 3D depth maps in multiple views. Uncanonical pose conditions have flattened geometry in novel views. Only when the pose condition is canonical can the synthesized images maintain shape and texture consistency across multiple views. Meanwhile, we find a clear depth gap between the face and background regions when generating good results with the canonical pose condition. First, we design an encoder to invert input image into W plus latent codes. The W plus latent codes are fed into a pre-trained EG3D generator to get triplane W plus and rendered into reconstruction image. Considering the canonical characteristic in EG3D's latent space, we use a canonical discriminator for adversarial training. Based on the depth differences between background and foreground, we use a depth regularization on depth maps. Next, we calculate the image residual between the input image and its reconstruction and propose AFA module to refine the F latent maps. The modified latent maps are transformed into mixed triplane by occlusion-aware mix and rendered into the fine detailed inversion image. We visualize the visible and occlusion regions in the input images and obtain the mixed triplane. Without the mixed triplane, the occlusion area from the source view is easy to produce artifacts in novel views.